Hello everybody, and thanks for joining me once again. We're looking at question 22 on the 2005 grade 8 level Gauss paper. 50 students were surveyed about their participation in hockey and baseball. The results of the survey were that 33 students played hockey, 24 students played baseball, 8 students played neither hockey nor baseball. How many students surveyed played both hockey and baseball? Okay. So this is a question that you could handle, say, with a Venn diagram or by carefully labeling things. You're going to be using what's known as the principle of inclusion and exclusion here. I'm trying to think of the best way. I think we'll go about doing this with a Venn diagram. So a Venn diagram is a great way to organize some information. So you typically draw a giant box representing the universe. This is everything, anywhere that you talked about. And then we've got two things that we're talking about, hockey and what's the other one, football or something? Hockey and baseball. So you get two circles. Everything in this, maybe we'll call it the blue circle. Everything inside the blue circle will represent the students playing hockey. So the total number that we should have in the blue circle would be 33. Then we're going to get, say, the green circle. And everything inside the green circle will count as the people who signed up for baseball. So the total number we should have in the green circle is 24. Okay. Now, in total, we have 50 students, as I recall. Right? 50 students. So, we had how many students not? We had 8 students who are neither in the baseball circle or the hockey circle. So, they're out here. Okay. So, we know 50 students in total. We've got 8 students outside the circles, so 50 minus 8, that's going to be 42 students played hockey or baseball. Maybe some of them played both, maybe some of them just played hockey, some of them just played baseball, but the point is we've got 42 students who played one of the sports. At least one of the sports. Okay. Now, we've got 33 students who say they've played hockey. We've got 24 who played baseball. So those should be the total numbers in these circles here. But if I add them up, I notice I've got 57, and that's way more than 42. What's going on here? Well, there's this overlap here of people who played both hockey and baseball who's counted as part of both groups. So we've got the 33 who played hockey. And this is some number, let's call it H, who just played hockey. Actually, what do we want to solve for? We want to let's make a term here. Let X be the number who played both hockey and baseball. So of these 33 students who played hockey, we have inside here we've got X. X played both. And then what's left over? We've got 33 minus X who only played hockey. Okay. And then with the baseball, we've got 24 who played baseball. X of those students are the ones who played both. And then the 24 minus X are the ones who only played baseball. Okay? And when we're adding up 33 and 24, we're adding the students who only played hockey, the students who only played baseball, but we're adding up the students who played both twice, counting them as hockey players and baseball players. So what we want to do is only count one. This is known as double counting, when you've counted the same thing twice for different reasons. And you want to avoid that. You can make questions like this with Venn diagrams much more complicated by having more overlaps, and you get things like double counting, triple counting. You have to include some things in your count and get rid of other things by appropriately subtracting. Questions like this can get much harder. I do a lot of these when I'm working with students at my university's sort of finite math counting class. Okay. So, if we want to get an accurate read, 42 students, well, these 42 students, well, we can count the people who played both, but we're only going to count them once. And then we've got the people who just played hockey and the people who just played baseball. And when we do this, we can correct our count. So we'll get 33 and 24 is 57, and then minus 2x. So this will be 57 minus x, and this is something we can solve for. We can solve for x. So let's rearrange. So 57 minus 42 is equal to x. Well, what's that? That's 15. 15 is equal to x. So that's how many students played both. And if you wanted to, now that we know that the overlap there is 15, we could go back and sort of fill in the rest of this Venn diagram. If 15 of the students are in the overlap, how many students who played baseball are left to just played baseball? Well, that would be 24 minus 15, or 9. How many students just played hockey? It would be the people who aren't in the overlap bit. And so there'd be 18 of them, because 18 plus 15 is 33. And the total inside the blue circle has to be 33. And we can even check 8 plus 18 is 26, plus 15 is 41, plus 9 is the total 50. So all students have been accounted for exactly once. And that's just a little extra stuff we can do to fill in the Venn diagram. What we really want is D15, the number of students who played both hockey and baseball. Okay. So that does it for question 22. Up next will be question 23. Hopefully you guys have been enjoying this contest, and I'll see you for the next question in the next video. So long for now.